started in a forestry school, largely because I wanted to get out of New Jersey, and I liked the woods, and I thought that would be as good a start as any. And it was, in fact, although I got more interested in wood than, say, in growing trees. So I went into a wood technology program at North Carolina State University, where, to my amazement, I was able to identify pieces of wood, as opposed to just trees. And I really, really enjoyed doing that. It was just so nice to pick up a piece of wood, cut the end of it, look at it with my hand lens, and know what it was. But in the United States, we have certainly a limited number of woods, maybe, at most 100, typically maybe fewer than 50. But when I went overseas to Liberia, there they have thousands of species of wood, and they're all really different, and they're also different in their anatomy. And it was just like, wow, this is incredible. And so it was really exciting to me. So I got really hooked on tropical wood anatomy and actually never really left that. Finished my degree on that and needed a job. So they were looking for someone to teach wood technology courses to forestry students in Ethiopia. Now, my first reaction to that is, Ethiopia? What have they got besides desert? Well, it turns out they have maybe 4% forested land. And because they have so little forestry land, they have to pay attention to what they've got. So that's what I was there, teaching the forestry students basically the properties of the wood and how they could better preserve the resource they had and maximize its utilization. I've given classes in Central America, Honduras, Guatemala, Nicaragua, on how to identify the wood to their forestry and customs things and police, people that basically are supposed to be checking up that the resource is being sustainably used and that people are not taking trees which should be protected and trying to sell them by claiming that they're something that they're not. And to do this, you have to teach them how to identify the wood, or at least identify the wood well enough that they can hold it until it can be sent someplace, like to another lab in the United States, for instance, where you can more definitively determine what it is. But it's often very hard because many species look similar, and you find that, like, two species of mahogany in Nicaragua, one is prohibited, the other's permitted, and so all of a sudden, all of the species that they're cutting are the ones that's permitted. Whereas previously, when they didn't have rules, it was the other one that was being cut. So that's a little suspicious. It might be true. But what happens is one of my colleagues in Oregon uses spectrographic methods, and those are really reliable for the species that it works. Apparently, it doesn't work with all species, but basically he and I work together. We have 100,000 wood samples at the Forest Products Lab. I send him just little slivers of wood, and he puts them in his spectrograph, and he builds up this huge database of chemical signatures of these woods. And so that by taking an unknown, you can put it in there, and it will match something up, and it does a really nice job of separating species that you would not otherwise be able to separate, because wood anatomy has serious limitations, the chemistry of the wood much fewer. Although he tells me that there are some groups that still can't be separated by his technique. But with new things coming up all the time, that's the way this would probably work, is that someone on the ground would look at a piece of wood, decide that it was or was not probably what the manifest said it was, and then either permit it or maybe send it to a better lab to find out. So that's where I am now, is basically wood identification of endangered species and how they can be distinguished from the species that are not endangered. And that's no easy task, but doing something is better than doing nothing. And you never know when something might work.
Where in the world do you believe the first trees originated from?
You know what? I have no idea. I would guess, based on basically, there's what we call primitive anatomical characters and advanced anatomical characters. And for instance, the softwood trees, the pines, the spruces, they're a much more primitive. So I would guess that maybe in the temperate region, maybe not the far north, but someplace in the mid-latitudes is probably where they started growing, if I had to take a guess. But that's all it is a guess. Because certainly the diversity is much higher in the tropics, but that's because the climate's different. You have many different you have many sites that have very different ecology, even though they're close to each other. And so that would spur diversity. Whereas here, the harsh conditions perhaps would limit the number of things that could develop differently than what was already there and survive.
What efforts, if any, and if it's possible, is being done to reinstate trees that are near extinction?
Well, there are certainly efforts. When I was living in Costa Rica, one of the research stations there had different trial plots, they called it. And they were planting various species of mahogany and teak. And right, they basically, they were trying to see how they would do. And I would say that they're not doing that well. Some of them, because they were like teak does very well in some areas, but not in others. But sometimes a pathogen will enter in there and kill them all off. And because they're in nature, especially in tropical forests, you sometimes find one stem in every 5 square kilometers. You put them in a plantation and all of this stuff is together, and the pathogens just can, once they get in there, they just decimate everything. So there are certainly problems that you have in trying to grow the resource. Now, other ways is maybe to grow individual trees, but that's too expensive to do on any practical scale, and I don't know how it would work anyway. So, yeah, there are efforts to propagate these, but whether they're going to restore the resource to the condition that those of us that appreciate the ecological aspects of the forest and not just the commercial aspects, I'm not so sure. I mean, it certainly works on a commercial scale for trees that are, pine trees in the United States. I mean, they're just huge pine plantations that propagate a resource that is very profitable. But also they have a rotation of 25 years. They're not concerned about growing the trees for their full lifespan, and they're able to control the pathogens, either chemically or otherwise. Right? So I would not look at propagation of rare species as a solution to the problem. My view would be you got to let the ones that still exist stay where they are and propagate naturally.
Is there anything similar to DNA testing that can help identify wood species?
People are working on that. The trouble with that, and this is sort of like things that I would have said were impossible are now being done routinely. DNA, the problem with DNA is that DNA traditionally has had to come from living tissue. So is there DNA that's usable in wood? Well, maybe. I mean, one of the people at the Forest Products Lab is looking at the DNA question, trying to find out, can you salvage DNA from dead wood and determine what species it is? And so far, no answer. But just like a lot of other things that I would have said, gee, that'll never happen, maybe somebody will figure out a way to do it. I mean, DNA testing in people, that was unheard of 40 years ago. Now it's routine.